The hot and neutral wire supplying DC power to a light rail commuter train carry 800 amp and are separated by 75.0 centimeter. What is the magnitude and direction of the force between 50.0 meter of these wires? Okay, so we are given two wires. Let's represent them something like this. Okay, this one will be the hot one. The current is going to be I1, for example. Now, when the train is in operation, the circuit has to complete. Therefore, current will go in the opposite direction in the neutral one. So this will be I2. Now, I2 and I1 are equal because it's a complete circuit. So I1 is equal to I2. Let's represent them by just I. And that's equal to 800 amps. And the distance between these two wires is given to be 75 centimeters. Let's represent it by D. And D will be equal to 75.0 centimeter. And that's equal to 0.750 meters. And we are required to find the force exerted on each other on their 50 meter long portion of the wire. So let's call it L. And L is 50.0 meters. So we are taking portion of the wires, only certain lengths. And we are required to find force. Now to calculate force we need permeability of free space, which is given by 4 pi times 10 to the power of negative 7 Tesla meter per amp. And what we are required to find is the force. Let's calculate the magnitude. The magnitude will be F, and we know that force per unit length of two current carrying conductors is given by permeability of free space, current in one of the wires multiplied by the current in the other wire, divided by 2 pi and the distance between them. Alright, so we're looking for the force, so we can multiply both sides by L. Therefore, F will be equal to mu naught times, now I1 and I2 are equal in magnitude, therefore can be I squared, multiplied by L, divided by 2 times pi times t. Let's plug in the numbers. Mu naught is 4 pi times 10 to the power of negative 7 Tesla meter per amp. And the current is 800 amp squared, multiplied by the length, which is given to be 50.0 meters. Divide that by 2 pi times d. And d is given to be 0.750 meters. Alright, pi versus pi. We can also simplify here 2. 4 divided by 2 is 2, and this is going to be 1. So the products of the numerator divided by 0.75 yields 8.53 newtons. All right, as for direction, you can see I1 is in this direction and I2 is in the reverse direction. That means the two currents are opposite one another. When the currents are in opposite direction between two current carrying conductors, the force that exists between them is repulsive. So this is going to be repulsive.